Today we're talking about solution stoichiometry, and I've been really excited about that all week, so I wore my inspirational t-shirt. Yeah, I know. Okay, we need you to remember the big picture of stoichiometry, because the big picture of stoichiometry is going to be the same. All we're going to do is change some of the details, because the whole idea of going from some measurable thing to numbers of moles, that's going to change, because we're now talking about solutions. Going from moles to moles, well, it doesn't matter what form those moles are in, solid, liquid, or gas. Getting them from moles to moles is the same. And finally, going from moles of unknown to that measurable thing of unknown, that's going to change, because we won't necessarily be stopping with the mass. So our start point and our finish point might be a bit different, and how we get to moles and out of moles might change, but really we're trying to accomplish the same things. So let's go back and review stoichiometry, because it's been a while. If the question was this, a nice mass stoichiometry, we can do this in our sleep. If the question was here, and you can read, I'm not going to read it to you, but if we started with a mass and we were finishing with a mass, this is what it would look like. And I'm doing the full one line. If you like 3 individual steps, great, knock yourself out. But then the units would cancel out. Got to be one on top, got to be one on the bottom, and that would go on the next one on top, one on the bottom, one on top, one on the bottom, so that all we have left is the mass of the thing that we are looking for, the mass of unknown, or the measurable, because I can measure masses of the unknown. Well, what's different with solutions? Well, with solutions, we don't measure mass, because we'd have all that solvent in there as well. How do we convert from that measurable thing, from volume, into moles? Well, instead of mass divided by molar mass, number of moles of solution, or solute rather, is concentration times volume. And then how do we get back to something that we can measure, like a volume? Well, that is number of moles divided by concentration, molar concentration, of course. Okay, so here's a question. And the question will look kind of similar. You've got a reaction, it's going to be balanced, and you're asked something that's hopefully obvious, that is stoichiometry. The difference is now it doesn't say anything about mass. It says I want to finish with a volume, and I've got a concentration, and I'm starting with a volume and concentration. Well, our plan is going to be the same. We want to start from the measurable thing that we know, in this case 150 milliliters, convert that into numbers of moles, and I've got the conversion factor right there. I don't have to go to the periodic table and look things up, so it's actually a bit easier. So I'm going to do concentration times volume, and then I'm going to convert that, sorry if that was a little bit too quick, convert that to moles, and that's going to be the same ratio, same kind of ratio. I get it the same way as I always have. And then I'm going to convert from moles of unknown rather to measurable thing of unknown. In this case, it's a volume, and for me the volume is number of moles divided by concentration. So it's actually going to be kind of familiar. So to run this question through, and pause it as you need to, the number of moles of the known is going to be the concentration times the volume. And I get number of moles of known. Then I'm going to go from moles of known to the moles of unknown, and you may have to rewind a little bit to see what the question was asking you for, but it was asking for, I hope, number of moles of aluminum chloride. Well, ratio is the same. I get the recipe from the balanced chemical equation, I get the one value there from my previous step, and I calculate the new value. That's not where I want to stop though. I want to stop at a volume, which is my measurable of the unknown. Volume is number of moles divided by concentration. In this case, the number of moles, previous step, concentration from the question, and my final answer. I could leave it as liters, I could convert it to milliliters. Doesn't really matter as long as I'm clear in my unit that I've labeled it as. Too easy. Okay, could we do this in a factor label method? Of course we can do this in a factor label method. All we have to do is pay attention to our units and make sure that they all work out. So, one of the units has to be on the top. Whoops, one has to be on the bottom. I thought I did that. And then I can cancel them out as I go through. I must have done it on another one then. Okay. If I have a balanced chemical reaction and I'm asked to find a mass, but I'm given a volume and a concentration, now what? Same thing, because I'm still going to start with a measurable, convert it to moles. I'm going to go from moles to moles, and I'm going to go from moles to measurable. And it doesn't matter if I start with a liquid measurable or mass measurable, and it doesn't matter if I need to finish with a liquid measurable or mass measurable. The process will be, well, big picture the same, little details a bit different. Again, big picture, same thing. Okay, so we're going to do this, follow along, push the buttons yourself, make sure that it all works out, make sure that it makes sense to you. Okay, here's what I have. Okay, I like to label it out, but you don't have to. Okay, I'm going to run it as a factor label method because we're pretty familiar with stoichiometry. Again, I started with a liters of solution, so I have to cancel that out by putting liters of solution on the bottom. That meant the number of moles of solution, or solute, I guess, goes on the top. They're going to cancel out. I knew I did it somewhere. Then that leaves me with number of moles of known. That I'm going to convert to moles of none known using the ratio step. 1 unit goes on the top, 1 on the bottom, cancel out. That leaves me with moles of unknown. But I don't want moles of unknown, I wanted mass of unknown. Grams on top, because that's my mass unit. Moles on the bottom, so they cancel out. I'm left with, the only unit left is grams of, in this case, aluminum hydroxide. That's it. Well, push the buttons and you end up with that many grams. Okay? If you like doing it in individual steps, it's going to look a lot like the previous one, except now the final step, I'm not using the volume, I'm using masses. Too easy. Okay, I am going to leave you the one because it's important for you to try one. We'll check it in class. We'll do more in class. Please be aware, though, that we can also run it the other way around. I'll mention that in a moment. So here's the question. Please pause it. Please write this down. Please solve this, because otherwise, what's the point? Okay? Okay, like I said, we don't have to start with a volume, finish with a mass. We could start with a mass, finish with a volume. We could start with the volume, finish with the volume, and we know from before we could start with a mass and finish with a mass, but that wouldn't be in the unit dealing with solutions. So just so you know. But the big picture for stoichiometry is always going to be the same. Hope this was okay. We'll talk to you in class. We'll try a bunch. You'll be masters in no time. See you then.